So last week we were talking about all the design aspects and all the design elements that went into making these composite hatches work for our boat here on the Pikea. This week we'll actually show the process and what's involved, because there's quite a bit involved in making the frame and the actual hatch lid itself. Yeah, let's have a look at the materials that I use, the molds that I've had to make, and then the actual process of putting it together. So we'll cover all of those bits in this video, and hopefully you'll learn something new. So let's start with the molds. Okay, so the molds are the primary part. Nothing can happen without the mold. And yes, we do need molds. I try to build as many things as possible without molds and tooling, because in my eyes, molds and tooling, unless you're making multiple items, are one-use, single-use plastic item. That's my take on it.
Wasteful, I think's the word.
Wasteful, yeah. If you can use things as many times as possible, or go through the process and actually build it without having to have something thrown away, then fantastic. But that's my little green hat on rant for the moment. So yeah, let's look at the molds that we have. We have a multi-element mold here because we have our flat table, which is part of our mold, and as everyone will know through watching lots of things that we've built so far, this table has had extensive use. Is getting a little bit tired, but has a lot more to go. And it'll have to have a lot more to go because we have a lot more things to build. So we've had to make two sets of molds for the composite hatch. We have, this is the gutter / tray mold for the hatch, and we also have the actual hatch lid mold as well. And you sort of wonder, why have I got a hatch lid mold? The hatch is just, lid is just flat, right? Yeah, no, of course it's not. So you can see here there's a fair bit of geometry that we need to accommodate for. As I spoke about in the design side, that geometry is the seal gutter, so that the seal is contained and it helps improve the performance of the seal, etc., because it's not just a seal sitting out there floating around. Anyway, talking more about design here, we need to talk about the build. Plastic that I'm using. These are plastic 3D printed parts. We print them on our bamboo 3D printer, which is here on board the boat. Obviously you can see it's quite large, so it all doesn't fit in the printer. So I've had to print it in sections. Also, we have two different size hatches on this boat, which is a major pain in the backside. There's an area on the deck in our aft cabins where we can't fit the full size hatch in, so it had to be 60 millimeters shorter in one direction. So you can see here there's a 60 mil section here, which I dropped out and could actually make the mold shorter. So I didn't have to build two molds. I actually had a mold could modify to accommodate two different size parts. You'll also see there's a join here transversely on the thing. This technically we could drop out and make a different dimension mold this way, but in the case of what we're doing we didn't need to. But this was actually put in here primarily so we could fit all the pieces on the printer. Now you'll also notice that in my mold and 3D print design, these are joined together with like jigsaw puzzle pieces so that things locate into the correct position when I'm assembling this. Originally I had this so that it wasn't all glued together, it was just jigsaw puzzled together and it was doing fine, but I'm on frame number 4, I think. 1, 2, 3, 4. Yeah, I'm on frame number 4, and these were struggling. So to have, I've got
Right, when you say frame number 4, you mean you've made 4 hatch frames?
Correct.
Not 4 molds?
Correct.
Okay.
The actual finished part number 4. And to get that out of a temporary mold is doing pretty well, and I've still got a lot more to go. So I actually have to take care of these molds. They're very delicate as far as a mold is concerned, so there's a lot of care that's needed during the demolding process. And also maintenance wise, making sure they're well waxed, etc., etc., etc. So they are very cheap, very adaptable, and I can modify these molds very easy thanks to the whole 3D printing process. It's changed the way we manufacture things. So you can see here, we've actually had a little bit of shell wall collapse. This is one of the issues with the 3D printed molds, is making sure that they're tough enough to survive a full vacuum. So there are some small signs of it having a hard time. It could have been, it's a bit of an odd place for it to have collapsed a little bit. Yeah, you can see that the shell has collapsed a little bit, and you can see the infill in there. So you need to play a little bit with the infills and the wall thicknesses of your 3D printed molds, and it's a little bit of experience, and each mold is slightly different as well, because if it's a big flat span, it needs more supporting structure underneath versus the small stuff on the edges. So there's a little, I can't give you a hard and fast rule with regards to that. That is a little bit of a experimental experience, suck it and see sort of thing. The finish, depending on what you're trying to achieve out of it, I've found that the PETG actually sands quite well. So this particular mold that's on the table here at the moment, that whole thing was actually sanded. I sanded all of the layer lines out. So I started with a 150, did a 220, and then waxed it. In some areas I actually went on the edges where the draw is difficult. I gave it a quick wipe with some, quick rub with some 400 grit. This hatch one, I actually haven't sanded at all. I have some pretty big draw angles on things in the hope that I didn't have to sand it. I've pulled 4 parts out of it, and so far it's been okay. I'm tempted to give it a sand and a re-wax to see if it's a little easier. I had a little bit of trouble with the last hatch. Finishing wise, depending on how many times you want to use it, what sort of finish you're trying to get off the tool. Generally speaking, if you've got a 3D printed part, you're not going to have an A-class finish. So that means you're going to have to post-finish the part, sand it and paint it afterwards. There is the possibility that you sand this and then paint it to an A-class finish, and then you can get an A-class finish part off your mold. Anyway, we're talking completely about whole different projects and other things. So this is our 3D printed mold for this hatch, and that's a little bit of what we went into to actually make the 3D printed mold.
220 is not that finer grit, really, Shane.
No, it's still pretty coarse as far as mold's concerned.
Yeah.
Yeah, so I get really heavy-handed with the release wax, and I'll show you that in a minute. But a couple of really cool things is in the actual mold, because it's 3D printed, we can 3D print reference marks, trim lines and stuff like that. So there's some small details in here that when the part is molded and gets released, there's like little 0.2 and 0.3 millimeter reference marks that stand out quite clear in the finished part that I can sand and trim the finished part down to. So 3D printing has some really cool advantages over traditional mold making, in that you can put some really cool features built directly into your mold. Right, let's talk about making sure this sucker releases. Okay, yeah. Oh, another thing you got to be very careful is temperature. Plastic 3D printed tools are totally dependent on the temperature resilience of the plastic you printed out of. So PLA, PETG, all those sorts of things are low temperature plastics, so you can't get them all. So post curing and stuff like that is out of the question. You've also got to watch out that if you're infusing large parts on it and the resin gets warm during the curing stage, and it doesn't warm up and soften this, and particularly under vacuum, it implodes on itself. So really careful with the temperature on this side of things. There is, if you do use things like the carbon filled nylons, totally different program. We've actually been making pre-preg in the oven 120-degree cure stuff with 3D printed molds. So yeah, it's 100% dependent on the material you use, just like if you were making a normal mold from wood, carbon, e-glass, sand, whatever it is, whatever you make the material of the mold with, be careful the process that you put it through. So one of the things I have to be a little bit careful of is when the polyester cures and the thicker hatch rims, it does get warm. So I've got to just make sure it doesn't get super warm, and I can't post cure on the mold. The next step, we got to make sure that everything releases. If your mold was relatively simple, you would, like you saw us with the bulkhead penetration, we actually put the Teflon film directly on the 3D printed mold itself. So it's nice and simple.
That's behind you, by the way, if you wanted to pick one up.
Oh yes, look at that. Here's one that was prepared earlier. So yeah, you might have seen us using these. And no wax used on these. These are just purely Teflon wrapped. The geometry is relatively simple, so that all works. No dramas at all. Yeah, so there's an example. And if you can do the Teflon film option, it's really cool. Yeah. The other option is release wax. Normally doesn't come in a jar, but this is leftovers from a job a long time ago. Someone I helped out put some wax in a jar for me, and yeah, I'm happening to use it. This is basically TR, high temperature wax, pretty stock standard industry normal wax for waxing normal molds. Okay. What's not normal is how I generally use it. Most of the stuff I do, I don't tend to chase A-grade finishes because everything is post-processed with sanding and painting. So it gives me more opportunities to do things with this wax that others wouldn't. The other option is, you saw me using this stuff with the stanchions when I was making the stanchion sockets. This is a spray-on release wax. Super cool. Really like this stuff. Only reason I don't use this is because when I'm using it inside, you can see we're working in a small space inside the boat, is that the wax tends to, in the overspray, go everywhere. So, and I want to keep it for other more technical jobs, right? Where I can use this, I don't need to use this. So either or, you get the same result. It's just that this one, there's a couple of other little tricks I can use this with this one that I can't with this one. So. Yeah, so the standard wax, it's quite cool in that when it comes out as a bit of a paste, and when I apply it super thick, right? That sucker is going on there thick as thick can be.
What are you applying it with, Shane?
That's just a little piece of rag. I even, at times, will just put it on the end of my finger like this and actually rub it into, if there's a little bit of a dint in the seam, I will actually just rub that sucker over it so that I am getting bucket loads of wax on the job. Okay, if you're chasing A-class finishes, do not do this because you will not get an A-class finish. You will get a very dull, very slightly textured finish, and you will get wax transfer 100%. So do not do this if you want an A-class finish.
So when you keep saying A-class finish, are you talking about a piece or a part that once you take it off the mold is ready to go, it looks amazing?
It's that.
Don't sand it, don't touch it.
Exactly. It's that beautiful, shiny,
carbon fiber,
finished carbon fiber, or
whatever, shiny.
You look at your brand new boat that's been pulled out of the mold, the nice, smooth, white, shiny gel coat finish. That's typically an A-class finish. It's something that is finished, ready to go. You don't have to touch it anymore.
Okay.
That's an A-class finish. So you can see I just get it on there, and I get it on there thick. All right. I'll leave that on there relatively thick. It will dry out and harden. Takes a little bit longer because it's gone on there pretty thick, but it's safe. And that's, at the moment, that's the primary focus, is to make this a safe and easy release. Because I know I'm going to be post-processing and sanding and painting inside these hatch rims and modifying and cutting drain holes, and all sorts of stuff's going to happen to this. So to get an A-class finish is not part of the process. So that's the waxing, the releasing. Okay, you'll see there's plasticine here. Plasticine I use to give me a small fillet in the corner, and also keep the mold from whatever small gaps and undulations are under the actual mold and the table. That doesn't let the resin get in under there, so it acts as a little bit of dam. Let's throw that on the floor. So part of the process is going around and sorting the plasticine out, making it all nice. And if there is any dings and dints and where my jigsaw puzzle joins are, I will typically fill them in with the plasticine as well. So I'll wipe the plasticine in and over this part where there's a little join. So this will actually leave a ridge if I don't plasticine over it. And then with my highly technical tool, I just flatten it off so it's a bit of fairing for my actual part. And then to give it the final fair, because the wax has solvents in it, like I think it's kerosene from memory, you wipe it and it will actually melt the plasticine a little bit, and by rubbing it, it fairs it out. And so the plasticine will only be left down in the ridge. And you can't press too hard, obviously, otherwise you'll scoop the plasticine out of the ridge. Okay, so now I'll just go around and plasticine the whole thing up, get it ready for the next step. Right, so mixing gel coat. Why am I mixing gel coat? So I'm not a fan of gel coat, but it has its place. And here it has its place. Okay, I'm gel coating the complicated geometry part. The reason for that is it creates a nice little primer for me for when I paint it later. It means it gives me something to sand like a primer so that I can paint it, and it doesn't mean that I'm sanding down into my resin fiberglass. So it just makes the painting process a little bit easier. If I was doing this in epoxy, I quite clearly wouldn't be able to use gel coat, because polyester gel coat is only recommended for using with polyester and vinyl ester or your styranated resin systems. We have used these gel coats in the past with epoxies, and yes, it does technically work, but no, don't try it unless you are experienced, because it's a pain in the backside. There's a lot of caveats with it. So, and I won't go into that because that is a whole video or two on its own. But yeah, if you were to do it in epoxy, I would actually use, and it's a trick I've used in the past, where I put an epoxy primer down on the mold. So you put the epoxy primer down on your wax mold, it goes off. You give it a very light Scotch-Brite, depending on the primer. Some of the primers you can just go and laminate straight onto, and you get great adhesion. A few pro tips there. You'll notice that I've also taped out with my yellow masking tape a perimeter around the white hatch rim. Now that's for a very specific reason. That is because that is my outer trim line for my hatch flange. So by doing that, it gives me an actual little physical ridge bump. And when I gel coat it, I'll gel coat it and then remove the masking tape. That then gives me a physical white line edge to also trim to. So saving myself a little bit of hassle down the track. Okay, so you can see I'm peeling the tape here and it's leaving a nice crisp line. Quite important to make sure that you peel the tape off before it gels or cures. Mistake I like to make. Probably doesn't help during summer as well, where it kicks so fast that you barely get enough time to peel it off before it goes. But anyway, there you have it, gel coat applied. Now, this is gel coat and not flow coat, so there is no wax in this, so this surface will always remain slightly tacky, and I use this to my advantage when I am applying the first layer of glass down on here, because it's got a little bit of stickiness to it still on the surface, and it means that I can stick my first layer of 300 gram cloth onto it without having to use spray tack. So yeah, it's a nice little little feature of the gel coat. Now I go and cut some material. So we've got the demolded hatches, or hatch rim. There's the demolded hatch. So let's start with the geometry and the accuracy. So you could see that we use the 3D printed mold to create the geometry. This gives us relatively accurate geometry without crazy expensive tooling and all the rest of it. So we almost get, I wouldn't say CNC quality, but you know, it is a computer numerically controlled machine that printed out the tooling. So it's pretty accurate. The geometry you can see is relatively complicated, particularly with the hatch. Grab the hatch here. You can see at this end of the hatch, there's some complicated geometry that stuff had to go around, and it's symmetrical and it's the same on each side. So using the 3D printed mold essentially gave me a relatively accurate and consistent piece of tooling for me to build these with. So the 3D printed molds are a good thing, and it achieves great, cheap, accurate tooling for me to work with without having a crazy workshop to do it. Before I sanded it, I did take some footage. 3D printed really thin marks that I trimmed to. So there was a small edge mark here that I trimmed to, and that was like a 0.2 millimeter thick layer that I put in there, and it gave me a trim line to actually trim all this stuff out to. You'll see these little dots here as well. These little dots sort of help me locate where the hinges go. So there's all these other little features that I can add into the 3D printed mold for me to work to as guidelines to trim the actual finished part out with too. Now, the gel coat surface finish. I've used the gel coat for two reasons. One, it gives me this base, primed base to work with that's white. So it makes my job of painting in and around these complicated geometry much easier. So I can actually see this hatch. I've sanded it. This is actually ready other than a clean up for paint primer. So I'll prime where I don't have the gel coat, but where the gel coat is actually not far off ready for top coat. The other reason that gel coat's pretty cool is in the case of our 3D printed molds, the gel coat, I tend to find releases from molds much easier than the actual primary baseline resins that the part's made from. That's due to, I think, shrinkage. When the gel coat's curing, it shrinks a little bit, not pre-releases itself, but you know, it's got some internal shrinkage on the surface that just makes it that much easier generally to release. That's just been my experience. Also with the gel coat, you can see the plasticine still here, is that the gel coat helps create a seal. So you saw me apply the plasticine in this corner, then I gel coat over it, and that then sort of creates a barrier, another barrier where the actual infused resin can't dive in under the mold here. So it sort of helps not encapsulate the whole thing in an infused resin barrier. The resin comes in from the other edge, but doesn't come in from this edge. Yeah, you can use the gel coat to help seal off areas as well. Obviously, for the whole process of the trimming and cleaning up, the remaining plasticine that transferred from the actual tooling to the part has to be removed, and that has left a nice little sort of chamfered edge here, so it's not a razor sharp corner. On this other side, it's pretty close to a razor sharp corner. That's because that is my printed hard corner, and I want that to be relatively hard and sharp because that's part of my sealing blade surface. It will be around it a little bit naturally with the sanding for the paint, but it generally stays pretty sharp. Right, now let's talk about why I use the masking tape. So remember, I used the masking tape to define where my gel coat went on the table. I use that, you can see I now actually have a clean and clear trim line right, where the gel coat stops, you can see then there's my overhanging glass. So it's very easy for me now to come along and trim to this nice straight tape pulled line that I defined earlier. You can see where a little bit of work in the setting up stages prior to infusing this has now saved me a heap of time. Right, so when I trim this, obviously I'm going to get I use the jigsaw to trim this edge. I don't use a 4-inch grinder with a cut-off blade. The reason is that when you're cutting this stuff with the 4-inch grinder, it gets hot and the resin has a low HDT, so it gets soft very quickly. And what that means is that the resin gets soft and then just sort of rolls out, and then you end up burning the glass rather than cutting it clean. Then you give it a sand and trim the final edge. On the inside here where the blade is, the sealing blade, you can see that I've got excess material when I molded it, right? So you can see there's a bit of a rolled out lip there. So I need to trim this back down until it's flush on the inside here. So that's what I've got to trim. So I'll cut this out with a jigsaw, sand it, make it look good. I will then trim this inside flush with the actual laminated edge. So that will give me a reasonably consistent thickness of my sealing blade. And then I need to prepare this surface here. Right, this flange here. Yeah, I got a bit rough and rugged when I was pulling the peel ply and stuff off here. So I pulled a little bit of my bloody 300 gram skin off, but you didn't see that. And it's going to get sanded, so it doesn't matter too much. So I actually need to taper the laminate here. I'm going to sand from full thickness out here to basically just the thickness of that very first 300 gram skin that I put out here. So it's a tapered edge, and that'll be done all the way around. That's a little bit of a pain. It takes a little bit of work. When I laminated it, you may be able to see in the light of the camera here that I staggered the glass a little bit, so it saves me a little bit of sanding and grinding. But yeah, it takes a little bit of time to sand and taper that edge. It is definitely worth it when it comes time to fitting the hatch to the boat.
Saddle up and dance. Baby, take a chance. This cargo needs romance. Baby, take a chance. Saddle up and dance. Baby, take a chance. This cargo needs romance. Baby, take a chance. Saddle up and dance. Baby, take a chance. This cargo needs romance. Baby, take a chance.
There we have it. I have trimmed it all up, ready to go in. And so yeah, you can see the hatch lid sitting in the frame now. What can I say? That it's trimmed up. It was lots and lots of wonderful cutty, grindy, sandy, but that's all good. Of course, I've got to now work on fairing and finishing the top of this, but that's pretty easy and pretty rapid because it's just flat, so there's no dramas. I do also need to trim up and fit the angle that's here, so I haven't done that yet. Here it is. So this piece of Well, that doesn't work, does it? So I need to make some more angle. I thought my 2 bits of angle were long enough. Oh, the joys of it. So I'm going to need to laminate some more angle so that I can fit it in here. Because that ain't gonna fit. Alright. But in the meantime, I need to put this frame here into this hole here.